3 is on your handout. Number 3 says give the domain and the range of a relation, and this in general is a big topic. It's kind of followed us along for chapter after chapter. We've studied about domain and range. So there's a lot of equations that you need to be familiar with. The 10 basic graphs, all the conic sections, the logs, the exponents, all the graphs that we study, you should be able to spot those, pick out their basic shape, and then know your shifting rules. And then from that, you should be able to decipher the domain and range. So if you know what this equation looks like, if you know it looks like this, for a visual learner, you can look at the picture and tell the domain and range best. If you're more of an algebraic T-table follower, just deciphering the meaning of domain and range that way, you could do the T-table chart, which we have here, fill in the blank for some x, y's, and then sketch your graph. So if you're just nervous and you can't remember what type of graph this is, you should always be able to fall back to your T-table concept. So plug in for x, the first thing that usually comes to mind is 0. 0 for x would be y is the square root of 2. Plugging in 1 for x, the square root of 3, not nice numbers, so keep trying. 2 square root of 4, which is 2. And then think, well, could I have one smaller than 0, maybe negative 1. 2 plus negative 1 would be 1. Then y equals the square root of 1, which is 1. So that was okay. Can you plug in negative 2? 2 plus negative 2 is 0. The square root of 0 is true, it's 0. Well, can I plug in negative 3? And that's when you get an error message. The 2 plus negative 3 would be the square root of negative 1, which is imaginary. We won't be graphing imaginary numbers, so we can't do that. So it's not in the domain. Negative 3 is not in the domain. So there was a cutoff point at negative 2. Negative 2 is actually the shift of this graph. It's back 2 places. It's the square root function, and then you could think of that as x plus 2. It may be more natural to the way we're used to seeing it. X plus 2 and 2 plus x are the same thing. That is a grouped plus 2. It's under the radical with it, so we would think of that as being grouped on the x. And we've learned that you always do the opposite sign of everything that's in a parenthesis or grouped onto the x, so that's a negative 2 shift. Okay, another way is to say what would make this radical, the part under the radical, stay greater than or equal to 0, and then you could equation solve and see x is greater than or equal to negative 2. So any way you slice it, the furthest you go on the x-axis is negative 2, and then over the positive infinity. And it touches negative 2, so you should use a bracket. And then for the range, the lowest spot, and you can also see it in the T-table, the smallest y value was at 0. So 0 on up for the range. So any questions on that? You're also allowed to use your graphing calculator, so if you want to use the graphing feature and type in y equals that square root of 2 plus x, just make sure you use a parenthesis to keep the 2 plus x under the radical. And then you can see the graph and decipher it from that. Okay, number 4. Number 4 is a piecewise graph.
Which is not on the handout that I passed
not
out.
on the handout. You have 3 pieces. With different definition. It is a function, so there is no overlap of the x values. So very specifically tells you the definition for each piece of the graph, so there would be no overlap. 3 pieces on the graph. And what you want to pay particular attention to on this is whether you have an open circle or a closed circle for your piece of the graph too. We can tell the first part of the graph is a parabola, 2x squared. That's x squared is the parabola, and then a little skinnier because of the 2. We want a parabola over here for x values less than negative 1. So from negative 1 back, the picture should have a little curve to it. So looking at your choices, well, they all do. So that didn't really rule anything out. But notice it has a line under it, so this little graph, it should have a filled-in circle. Some sort of parabola coming down with a filled-in circle. still kind of hard to decipher because some of the graphs, this is running into the next part of the graph. So what you need to do to be sure is do a t-table value. Say, I want to know exactly what happens to this graph at x is -1. So at x is -1, if I fill that into my graph, 2 times -1 squared, which would be 2 times 1, is 2. So back 1, my graph should be up 2. And if you want some more points, you could plug in -2, -3, and make sure. But anyway, I need to be real specific about where that curve comes into my graph at, since the answers are close. Okay, the next piece of the graph, y equals 2, that's a flat line. Y equals 2 is a horizontal line through 2. That's why I see it shares that point. When I draw y equals 2, from -1 to 1, it runs into that point. At -1, it looks like it's filled in, but it's just because this graph hit that point. So it already had that dotted in. Otherwise, you would see an open circle on the ends of this next piece. From -1 over to 1, I would have open circles, but this graph happened to share that point, so it filled it in. The third piece of the graph, y equals 2x plus 1, that's a linear equation, so I should have some sort of line this way. It's a positive slope line, so something like this. So still, the choices are close here, I'll just have to say, so you have to be real careful to actually find what's happening at this particular spot. So I want to know, I'm going to have this graph for x values greater than or equal to 1. So what happens at that equal to 1 spot? If I fill in 1 for x, y equals 3. All right, this is significant. So for my last piece of the graph, y equals 2x plus 1, at the value 1 that I filled into, that one I've already used that one. We're talking about the third graph. I filled in x is 1, I get a y value of 3. So for the third section at 1, it should be up 3. Should start there, and then it's a line. It is filled in because of the line under it. If you wanted to get another point, say plug in 2 for x. At 2, you should get y is 5. So over 2 would be up 1, 2, 3, 4, 5. Connect your dots, and then that's the third piece of your function. So then pick the one that looks like that. Okay, let's talk about number 5. Number 5 talks about symmetry. We have 3 types of symmetry that we're studying and accounted for in this section. We have y-axis symmetry, x-axis symmetry, and origin symmetry. With the y-axis symmetry, x has to, whether you change it to positive or negative, x changed to a negative x comes out to be the same value. So this happens whenever you have all x's to an even power. So we'll call this an even function. Like y equals x squared is an even function. You can see it's a parabola. If you fold it along the y-axis, it meets. So any equation where all of the exponents, all of the x's exponents are even, you're going to get this effect where you could fold it along the y-axis. So that's not happening here. I've got an x to the 4th and an x to the 1st. So if they're all even exponents, or maybe an absolute value signs, or something that would make the x or negative x not make a difference, you get the same output for y. Whether you're over on this side of the x or this side of the x, you get the same output for the y. So that's y. For the x-axis, you can change y to negative y and it doesn't matter. Now this won't be a function because it's a sideways parabola, so it doesn't get called an even function because it's not actually a function. It's on its side, and that means the x repeats. So if you can change y to negative y and it makes no difference, that is an x-axis symmetry. Origin is if you can change x and y to negative x and negative y. And those are usually odd functions. So if all the exponents are odd, like y equals x cubed plus x to the 1st, That would be an odd function, and it would be symmetric with the origin. Y equals x, just the line. It rotates around 180 degrees, and it looks the same, so it's an odd function. Y equals x cubed. Looks like this. You rotate it 180 degrees, and it looks the same. So the odd function. Well, if you've got a mixture of even and odd, it's going to have no symmetry. So that's what's happening on 5. No symmetry. We have some even and some odd. And I'll tell you what else. If you use your graphing calculator and just type in this equation, you can look at it visually and tell if it has any of these 3 symmetries. If it folds along the y-axis symmetry and meets, or if it folds along the x-axis and you can see the graph meets. Or origin, if you can rotate it 180 degrees and it looks the same. That verifies visually those 3 symmetries. Okay, number 6. Number 6 is graph the function. So again, if you have your graphing calculator, just graph away. What we may do though on the exam, you may see choices to how is this shifted. Up 4 units, left 4 units, right 4 units, and so on. So you may have a choice that way to where it's not just a visual, but you're deciphering the shifting rules, which if it's grouped with the X, that's a left-right shift. Because it's grouped with X, we think left and right. And it's grouped, we change its sign, so it's a positive 4, so it would be a right by 4 places. So it would be an arc moved over 4 places. If you're not sure, you make a T-table. Okay, number 7 is more of the shifting rules. Knowing what each part of this does to the graph, again with the X, grouped with the X, that means it's right by 2. We do the opposite sign of what we see. So if it says X minus 2, we're moving it right 2. The negative flips it upside down. And then a 1/3 makes it wider. Makes it open slower, so right, it makes it look a little wider. So we've got an X cubed graph, looks like this, and it's shifted over 2 places. Would have been here, but it's flipped upside down, so it's opening something like that. Now this deciding exactly how wide does the graph look, just saying it's somewhat wider or somewhat more narrow, wouldn't be good enough to pick between choices. So if you still need to be sure, if there's 2 that are just shifted the same way and flipped the same way, which there are, I would then, like between A and B, you wouldn't be sure just looking at it. So I would want to put in a point. Okay, so I think this is critical for you, or use your graphing calculator. Plug in something for X. First thing that came to my mind is to plug in 0. So I plug in 0 for X. Y equals negative 1/3. 0 minus 2 cubed. Type that in your calculator. Figure that value out. Negative 2 cubed, I'll do it by hand. Negative 2 cubed is negative 8. Negative 8 times negative 1/3 will be positive 8/3, which is almost 3. So at 0, the graph I picked should be up around 3.